Okay, we've got 20 feet of framing. We're trying to maximize the area. So let's start with the framing idea. The framing, I assume, is this, this, this. Ooh, is it double here? Because there's one piece here, there's another piece here. I'm not sure. I'm going to say no. I'm going to say it's the outer frame. They're saying the outer frame. So we're going to assume that this is the 20 feet of material that they're talking about. So that's one of these sides. Call this X. That's two of these sides, and then it's this semicircle, which is the area. Sorry, not the area. The circumference of a circle is 2 pi r, right? So a semicircle is just pi r. And then we've got two y's plus an x. Oh, actually, we can say something here. This should all equal 20. This is the outside framing. But we can say something about r in terms of x, so it's not as complicated here, so we don't have as many variables. R is just half of x, right? So this is x pi over 2, or pi x over 2 is probably a better way, plus 2y plus x equals 20. So that's our perimeter. We can get y by itself relatively easy. We can subtract the x terms from both sides. So divide everything by 2, so we got 10 minus, we'll say 2x over 4, just to get common denominators, because this is pi x over 4. And the reason why I got y by itself is because I know when I try to maximize something with calculus, I'm eventually going to have to take a derivative and set it equal to 0. So we need to have everything just in terms of one variable. So the area of this thing is the area of the rectangle, x times y, plus the area of the semicircle. So that's pi r squared, and then we divide that by 2 to make it a semicircle. Like we said up above, the radius is just half of x. So we can get rid of one of those variables. It's half of x. We can clean up that fraction a little bit. That's x squared over 4. If the whole thing is being divided by 2, the same thing as multiplying by 1/2. So this, it's like this top term multiplied by 1/2, so multiplying that bottom gives us 8. There it is, all nice and neat, cleaned up. And we already have something we can plug in for y, so we're going to replace y with what it's equal to according to our perimeter equation. It's 10 minus 2x over 4, which is x over 2, I guess, in an easier way. And then minus pi x, pi x over 4. So that's the y that we replaced. Excuse me. Then we still have the term over here. And then we can distribute. Here, let's get common denominators while we're at it. So this is going to be 2x squared minus pi x squared, and it's all going to be over 4. Okay, and then that's our area equation. We could continue getting common denominators, but I think that's probably enough. Because we want to take a derivative to set the derivative equal to 0 so we can maximize it. So the derivative of this term, we should actually a little easier if we separate it. I forgot we're taking a derivative. So you can combine it like this, but I'm going to go back to this form over here. That's x squared over 2 minus pi x squared over 4 plus x squared pi over 8. And now we can take a derivative and then set it equal to 0. So the 2 comes down, 2 comes down here, so that's pi x over 2. The 2 comes down here when we take a derivative, so that's x pi over 4. And then we set that derivative equal to 0 and solve. Running out of whiteboard room though. So we're setting this equal to 0. To get x by itself now, we do need to have common denominators, so we can just have one term involving x. So this is 2x over 2. Actually, let's make them all have 4. So this is going to be 4x over 4 minus 2 pi x over 4 plus x pi over 4. And if we combine all those x terms, so we got 4x, this is 4x minus 2 pi plus another pi, so that's minus 1 pi over 4x. So I just combine the numerators because they all have common denominators. Oh, actually, you know what? I made a mistake with the order of operations. There should be, these are all x's, so this is like a negative 4. So I'm going to write it like this, plus a negative 4, then minus 2 pi plus 1 pi, so that's still minus pi over 4. And this is all x, because each of those was a term with x. So we can subtract that 10 from both sides. Multiply both sides by 4. We keep this all in parentheses because the whole thing is being multiplied. And then divide both sides by negative 4 minus pi. Let me see if they want the exact answer though. Nope, they said we can round, so we're all set to change this to a decimal. We want to divide this term from both sides. So we get x is, I think that's 5.6 when I checked with my calculator. Well, you can figure out negative 4 minus pi and then do negative 40 divided by that result. So that's x, that's the width. The height we said was y, and I accidentally erased what y was equal to. Let me see if I get it back. We rewrote at the beginning. Oh, and here, while we're here, we can do the radius. If 5.6 is the width, then the radius is 2.8, because it's just half the width, right? And then here I'll get the function for y back on the screen. There's y. 5.6001. Yeah, so to figure out what y is, now that we know what x is, you just plug in 5.6 in for x. And the rest of that's just simplification, right? So I'll leave that. Because every student, or most students, have a different randomization, so you still want to make that calculation. But you're plugging 5.8 back in for x to solve for y.